Baalbek, a city in modern-day Lebanon, is home to one of the most astonishing monuments of the ancient world, the Temple of Jupiter, whose foundation stones are among the largest ever quarried and moved by human hands. These enormous stones, some weighing hundreds of tons, challenge our assumptions about ancient engineering and have inspired both wonder and speculation for centuries. How could a civilization without modern cranes, trucks, or power tools transport and position such massive blocks with precision? The answer lies not in mystical technologies or extraterrestrial intervention, but in the extraordinary ingenuity, organization, and practical problem-solving of ancient builders. When we examine the evidence, archaeological, historical, and experimental, it becomes clear that the stones of Baalbek were moved through a combination of careful planning, simple machines, human labor, animal power, and an intimate understanding of physics and materials, all rooted in the cultural and social context of the time. To begin with, it is important to understand the scale of the stones involved. At Baalbek, several massive limestone blocks form a terrace platform that supports the ruins of the Temple of Jupiter. Among these stones are the famous trilithon blocks, 3 gigantic megaliths, each measuring approximately 19 meters 62 feet in length and estimated to weigh around 800 to 1,000 tons. Nearby, an even larger block lies in an ancient quarry, the so-called Stone of the Pregnant Woman, which alone weighs an estimated 10 to 1,200 tons. These stones dwarf even the largest blocks used in the construction of the Great Pyramid of Giza, and raise legitimate questions about how pre-industrial societies could handle such massive weights. It can be tempting to assume that the ancient builders had secret technologies or supernatural help, but there is no archaeological evidence supporting such claims. Instead, scholars have shown that prehistoric and early historic societies were fully capable of moving large stones, using techniques that, while labor-intensive, are grounded in the laws of physics. The Egyptians, Assyrians, Greeks, and Romans, whose knowledge intersected at Baalbek, all developed practical methods for quarrying, transporting, and positioning heavy blocks. These techniques were based on simple machines like levers, rollers, sledges, ramps, inclined planes, and pulleys, combined with the coordinated effort of large work forces and domesticated animals such as oxen. The first critical step in the process was quarrying the stones. At Baalbek, the bedrock was soft enough in places to allow artisans to cut massive blocks directly from the hillside, using chisels, picks, and wedges made of harder materials such as bronze or iron. Workers would carve around the outline of a block, then insert wedges into carefully drilled holes. By sequentially hammering these wedges, they gradually separated the stone from the bedrock. This technique is evidenced at the quarry sites themselves, where cut marks and wedge holes are clearly visible. Quarrymen would then trim the stone, shaping it for transport and eventual placement on the terrace platform. Once a block was freed from the bedrock, the challenge became moving it. For stones weighing tens or even hundreds of tons, the ancient builders relied on a combination of earthworks and simple machines. One widely accepted method involved moving stones on wooden sledges, large platforms with the stone placed on top, that were pulled along prepared paths. Archaeological evidence from Egypt, Mesopotamia, and other ancient sites shows that moving stones on sledges over lubricated surfaces dramatically reduced friction, making large loads easier to pull. A wall painting from the tomb of Dj-Hotep in Egypt, for example, depicts a colossal statue being dragged on a sledge while workers pour water in front of it, visibly reducing the effort required to move the load. At Baalbek, the terrain and distances involved would have required careful route planning. Workers likely prepared paths by leveling the ground, laying down logs as rollers, or creating packed earth roads. Logs used as rollers under a sledge act as primitive wheels, allowing a heavy load to roll with significantly less resistance. Teams of workers coordinated their efforts, pulling with ropes while others ensured the route remained clear and stable. Recent experiments with replicas of ancient sledges confirm that this combination of rollers, sledges, and human power can indeed move multi-ton objects over considerable distances without modern machinery. It is also important to remember that these operations occurred in societies where large coordinated labor forces were possible. Ancient Egypt, for example, mobilized tens of thousands of workers to build pyramids and temples, not slaves, as once commonly assumed, but organized laborers who lived in nearby worker villages and were fed, housed, and managed by skilled overseers. Similarly, at Baalbek, the Roman Empire had the administrative capacity and economic resources to organize large crews of skilled and unskilled laborers, animal handlers, stone masons, and engineers. If a block weighed 1.0 tons, a team of several hundred people, possibly supported by animals, could reasonably move it over short distances with the right infrastructure and planning. Inclined planes and ramp systems were additional tools in the ancient engineer's toolkit. Rather than lifting a massive stone straight upward, ancient builders constructed earthen ramps with gentle slopes that allowed loads to be pulled up using ropes and sledges. These ramps could be straight, zigzagging, or wrapped around the structure as it rose. Evidence from other ancient construction sites, such as the pyramids at Giza, shows clearly that ramps were an essential part of moving heavy stones into place. While the exact configuration of ramps at Baalbek is unknown due to centuries of erosion and subsequent construction, the principle remains the same. Moving a heavy block up an incline reduces the force required at any one moment. Another critical element was the use of levers. The principle of the lever, a rigid bar that pivots on a fulcrum, is simple yet powerful. By applying force on one end of the bar, workers can lift much heavier objects on the other end. Imagine inserting strong wooden beams beneath a stone and using them to gradually lift and shift it, moving it in tiny increments. This technique could have been employed not just for transport but also for fine positioning of stones within the temple terrace. Large stone blocks were often lowered into precisely cut fittings in the wall or floor, requiring delicate control at the final stage. This was accomplished not by brute force, but by systematic application of levers, shims, and adjustments. A process much like turning the tuning pegs on a grand piano, only with much heavier parts. One question often asked about Baalbek's stones is not just how they were moved horizontally, but how they were raised into their final vertical position in the temple complex. Ancient builders did not have steel or hydraulic cranes, but they did have wooden cranes and winches powered by human or animal labor. These would consist of a simple frame with a rotating axle and rope, essentially a giant capstan, around which powerful ropes were wound. Teams of workers, often organized in shifts, would pull on these ropes, lifting the stone upward gradually. Archaeological evidence from Roman sites across the empire shows that they used treadwheel cranes, large wooden machines powered by people walking inside a wheel, much like a hamster wheel, to lift heavy blocks during construction. The presence of similar machinery in the broader Roman world supports the conclusion that Baalbek's builders had access to sophisticated lifting technology for their time. It is also essential to appreciate that the Romans who rebuilt and expanded the sanctuary of Baalbek into the Temple of Jupiter complex were inheritors of earlier traditions. The site itself had been sacred long before the Romans arrived, with earlier Phoenician, Egyptian, and possibly pre-Phoenician structures. The Romans did not invent stone moving. They inherited and refined centuries of engineering knowledge. Their scribes, architects, and builders were not working in isolation, but within a tradition of practical mathematics, geometry, and empirical problem-solving that spanned the Mediterranean world. In addition to physical techniques, ancient builders benefited from detailed planning and surveying tools. Simple instruments such as plumb bobs, leveling instruments, and sighting rods allowed architects to ensure precise alignment and geometry. At Baalbek, the terrace platform exhibits remarkable precision in the placement of its massive stones. This precision was not accidental. It was possible because ancient builders could measure, plan, and adjust, skills honed over generations of monumental construction projects elsewhere in the ancient world. Some skeptics have pointed to the size of Baalbek's stones and claimed that even ancient techniques should not have been sufficient. However, experiments in experimental archaeology consistently show that with coordinated labor, simple machines, and carefully designed infrastructure, impressive feats of stone transport and placement are achievable. Teams working together with trained leadership can move extremely large objects using basic mechanical principles. That the ancient Egyptians built pyramids weighing millions of tons, and that other ancient cultures moved obelisks and colossal statues, demonstrates that technology defined by horsepower and human strategy, not modern machinery, was sufficient for the task. In the case of the Terrace of Baalbek, scholars today generally agree that the stones were moved incrementally and deliberately using combinations of sledges over prepared paths, ramps, levers for fine adjustments, and cranes or winches for vertical placement. The lack of surviving wooden infrastructure at the site is not surprising. Wood decays far more rapidly than stone. What remains is the stone architecture itself, evidence of enormous effort expended over decades or even centuries. The absence of preserved wooden ramps or cranes simply reflects the differential survival of materials over millennia, not the absence of those technologies in practice. Another layer of this story is the social organization required to coordinate such efforts. This was not a random collection of workers, but a structured labor force operating under systems of leadership, planning, and resource management. The Roman Empire had an administrative apparatus capable of organizing skilled and unskilled labor, allocating resources, and sustaining large construction projects over many years. Skilled engineers would have supervised teams of laborers, animal handlers would have coordinated oxen or donkeys, and masons would have shaped and finished stones with remarkable precision. This level of organization substantiates how massive stones could be moved without modern machines. Not through mythical strength, but through collective effort, knowledge transfer, and disciplined execution. At the same time, it is important to dispel modern misconceptions fueled by fantasy or internet speculation. Claims that Baalbek stones are inexplicable without modern machinery ignore centuries of archaeological research and experimental demonstration. While the scale of the stones is impressive, the methods of moving them are not only plausible but consistent with what we know about ancient construction techniques across different cultures. The story of Baalbek is not one of impossibility, but of human innovation. A reminder that ancient societies possessed deep practical intelligence and an ability to solve monumental problems with the tools at their disposal. Some researchers also explore the psychological and cultural dimensions of such monumental construction. For those involved in building Baalbek, the project was not merely a physical task but a sacred mission. Temples were seen as houses of the gods, cosmic symbols, and representations of divine order on earth. Moving massive stones was not just engineering, it was an act of devotion, political expression, and communal identity. This cultural context gave meaning to the work and motivated communities to commit resources, time, and labor toward a shared and extraordinary goal. In conclusion, the stones of Baalbek were moved without modern machines through a combination of ancient engineering techniques grounded in physics. Practical tools such as levers, sledges, rollers, ramps, and winches, coordinated human and animal labor, careful planning and surveying, and social organization capable of sustaining large projects. The evidence does not point to lost technologies, but to the remarkable capabilities of ancient builders who understood how to use simple machines in sophisticated ways. They harnessed the collective strength of coordinated teams, applied mechanical advantage where needed, and designed infrastructure that made even the largest stones manageable. The result is a monument that continues to inspire awe, not because it defies explanation, but because it reveals the enduring capacity of humans to solve daunting challenges with ingenuity, discipline, and cooperation.